So I need you to know this information about these functions. Let's start with the first function. The first function is f of x equal, f of x equal x. Don't confuse yourself when you see like f of x equal x, because always f of x it's y. The value of f of x it's y. That's mean y equal x. This is the function. How to graph this function? We already learned about that on section 2.1. How to graph any function? You're just gonna take 2 points, plug in here to get the y. So I'm gonna give you the points if you want to graph this one. So I already set up a table with x, y. You can use these points to graph the function. Let's do -2, 2, -2, -2, 0, 0, and 2, 2. You can graph these points. This is x, y. That means this is the point, -2, -2. And here's the point, 0, 0. And here's the point, 2 and 2. So if you want to graph this function, when you see f of x equal x, just use these points to graph the function, and your graph is going to be just a line like this. Here is x, negative x, y, negative y. It's going to be just a line like this. So you have to know the graph of f of x like this. If you want to graph it, you can use these points. Always x, y. Graph these points is going to be, the graph is like a line like this. Always you have to know the domain for this function is from -infinity to infinity, and the range also from -infinity to infinity. In case if they ask you about the domain and the range for this function. So I need you to know this information, how to graph it. You can use these points, or you can choose any x, plug in here to get the y, then you can graph it. So you have, this is the first function. We're going to use it on section 2.7. The second one, the second function, f of x equal x squared. Also, we're going to do the same thing. F of x equal x squared. To graph it, we're going to use the same thing, the table, x, y. We're going to choose any x, plug in the function to get the y. So I'm going to choose -2, the same, 0 and 2. I choose the x's, plug in -2 squared with parentheses is going to be 4, 0 squared, 0, 2 squared is going to be 4. That means at this point, -2 and 4, 0, 0, and here is going to be 2 and 4. So let's graph these points so we can get the graph of the x squared. 1, 2, 1, 2, 2, 3, 4. So this is the 0, 0, and here's the point, and here's the second point. So the graph for x squared always look like this. So always when they ask you, you see x squared, keep in your mind, this is the graph of x squared. This is the graph for the x, this is the graph of x squared. Here is another information, the domain for this function, always from -infinity to infinity. And the range is from 0 to infinity. So I have to put a bracket here, from 0 to infinity. That's if they ask you about what's the domain for this function, what's the range, the range, the domain from negative infinity to infinity. Let's write down the coordinate x, which is the same thing. And the range starts for the function from 0 to infinity. So this is the graph of x squared. Two types when we have f of x equal x. So when I ask you about how to graph x function, you can use these points. Already have to know here is the function of f of x equal x. So this is the function f of x equal x. This is the graph, and this is when f of x equal x squared. You have to know these two kinds of function because we're going to study the third one. If we have f of x equal x cubed, x squared, the third one is going to be x cubed. So let's do the third one, number 3. When f of x equal x cubed. F of x equal x cubed. How to graph this function? We're going to use exactly the same process. Let's try to do the table. This is the x. I need to find the y. I'm going to choose also 3 points, -2, 0, 2. You can choose any points. You don't have to choose these points. A plug in -2 cubed is going to be -8. 0 cubed is going to be 0. 2 cubed is going to be 8. Now we have 3 points, -2 and -2 and -8, 0 and 0, 2 and 8. Here's the point. We can graph these points to get the graph for x cubed. Let's see how it's going to be the graph of x cubed. So here is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2. So now the first point, -2 and -8, is going to be here. 0, 0, and 2, 8 is going to be here. So the graph of this function, always you have to keep it in your mind. This side goes down like this, and this side goes up like this. So this is the graph of x cubed. Always you have to keep it in your mind. So here is f of x equal x cubed. So every time in section 2.7, if they ask you about x cubed, you have to know this graph. If you want to graph it, you can use these points. That's why I need you to write down everything here.
Does the middle number always have to be 0?
It doesn't matter. You can choose any number. It's going to be exactly the same graph. Choose -1. -1 is going to be -1 here. Choose 1. It doesn't matter. Any number, you can choose it here. The graph of x cubed is going to be like this. Okay? But always keep in your mind, choose negative and positive number. Choose -4 and the 3 here. So you can cover this side and you can cover this side, okay? The main thing, choose negative and positive number. You can choose 2 numbers, -2 and 2. That's it. 4 and -4 and 2. It's going to be exactly the same graph. That's why I need you to know the graph of x cubed is going to be like this. It doesn't matter which point you can choose here. It's going to be the same graph. Now, the domain and the range for this function, the domain always -infinity to infinity. If they ask you about the domain for this function, just go ahead and write down -infinity to infinity. And the range also -infinity to infinity. So you have to know this information. Let's make everything easier for you on section 2.7. number 4, and how it's going to be look like. 2 more fractions, and we're going 3, in fact. This one, the square root. Let's see. Oh, yeah, 3. Now, the 4th one, if you have f of x equal square root of x. How to graph this fraction? If you remember the square root of x, we can't choose negative number on this fraction because negative square root of number is going to be an I. If you remember that, so I can't choose -1 or -2 because it's going to be an I, and we can't graph this one. So the domain, let's choose 0 and positive numbers. 0, 1, 4. I choose these numbers. Plug in here, the square root of 0 is going to be 0. The square root of 1 is going to be 1. The square root of 4 is going to be 2. That means the first point is going to be 0, 0. The second point is going to be 1, 1. And the third point is going to be 4 and 2. This is the x, and here is the y. So now we can graph this one, the square root of f of x square root of x. So always the graph for this function always going to be like this. 1, 2, 3, 4. So the first point is 0, 0. The second point 1, 1. Here's 1, 1. The third point, here is the 2, and here is the 4. So always this function look like this. Always f of x equals square root of x is going to be the graph like this. Just a line goes to the right side like this. The domain for this function always from 0 to infinity, because we can't choose negative numbers. So the domain starts from 0 to infinity. And also the range is going to be the same, because we're not gonna get a negative number, because the first number is 0, 0, so that means there is no negative number with the range 2. So always going to be like this. This is the number 4. 2 more fractions, and we're going to start doing the piecewise fraction. F of x equal the cubic root of x. This is the 5th one. How to graph this one? We're going to choose the same points. It's a cubic root, so I'm going to choose a number with the numbers with the cubic root. Here's x, here's y. Because I can't graph decimal number, so I'm going to choose -8 because there is a cubic root for -8. I can choose 0. I can choose 8. You can use these numbers. You can choose 6, 3, but when you plug in here, it's going to be decimal number, and it's hard to graph decimal number. That's why I'm going to choose these 3 numbers. You can choose -1 also, it's fine. So -8 plug in here is going to be -2. 0 plug in here is going to be 0. 8 plug in here is going to be 2. So the first point is -8 and -2. The second point is 0, 0. The third point is 8 and 2. So here is the 3 points. When you graph these 3 points, you will get the graph of the cubed. 1, 2, 3, 4. So let's graph this one, -8 and -2. Here's -2, and here is -8. and here is the 0, 0, and here 8 and 2. Always the graph for this function is going to be on this side, goes down, and on this side goes up like this. It's exactly like the x squared, square root of x, but from this side also. So this is the graph of the cubic root of x. You have to know when they ask you about the cubic root of x, if you want to graph it, use these points to graph the cubic root. The domain, always the domain for this function from negative infinity to infinity, because you can choose negative numbers and you can choose positive number. The range, the result also is going to be negative number and positive number. That's why the range also from negative infinity to infinity. This is number 5. And the last function, number 6, is the absolute value of x. This is the last function before we move into the next part. Alpha of x equal the absolute value of x. How to graph this one? Here's the point, x, y. For this function, you can choose any points, positive or negative. So let's choose -2, 0, and 2. So when you plug in -2 here, the absolute value of -2 is going to be 2. When you plug in 0, it's going to be 0. When you plug in 2, it's going to be 2. To graph this function is going to be, you can use these points. And here is 0, 0. And here is 2 and 2. So we have 3 points. We can graph it by use these 3 points. So the graph of the absolute value of x is going to be 1, 2, 1, 2, and 1, 2. -2 and 2 is going to be here. And 0, 0 here. And 2 and 2 is going to be here. So the graph for this function is going to be look like the V letter, like this. And from this side also. So you have to know the graph of absolute value of x is look like the V letter, start from 0 to infinity. So the domain, always the domain for this function from negative infinity to infinity, because we can choose negative number and positive number, and the range from 0 to infinity. So the range from 0 to infinity. So this is the last function. You have to know these 6 functions because we're going to use it a lot on next section, section 2.7. So the piecewise function, it's a function contains more than one piece. If you remember before, we have f of x equal 2x plus 4. This is a function, it contains one piece. So this is just a function. Now we're going to learn what's the meaning of piecewise function. Piecewise function, it's a function contains more than one piece. For example, you see f of x equal 2 pieces. The first piece, let's say 2x minus 1, and the second piece is 3x squared. Here, they're going to give you the condition. When x less than 0, that means when x less than 0, like negative numbers, you can choose this piece. If x greater than or equal to the 0, you can choose this piece. That's why it's called piecewise function. So you have two options, but you have to be careful which option I'm going to use. The option you're going to use, if x less than 0, that means if x -1, -2, -3, and keep going. If x is a negative number, I have to choose this piece. If x is 0, because there's an equal sign here, if x is 0 or positive number, I have to choose this piece, like 0, 1, 2, 3, and keep going. That's why it's called piecewise function. That means this function contains two pieces. This is the first piece. When I have this condition, all the x's less than 0, I'm going to use this piece when all the number equal to the 0 or positive number. I'm going to use this piece. So that's why we call it piecewise function. Let's start evaluate. If I ask you to find f to the -1, we already know we need to find the value of y when x equal -1. So tell me which piece I'm going to use. I'm going to use this piece or I'm going to use this piece. Where are you going to plug in -1? Here or here? You have to follow this condition. So you're gonna plug in, so x equal -1. Check these conditions. Where is x negative numbers? This condition, it says all the numbers less than 0, you're going to use this piece. Here, the condition, it says when the x greater than or equal to the 0, you're going to use this piece. Now x is -1. -1 goes here or here? Goes when x less than 0 or when x greater than or equal to the 0?
Less than 0.
Less than 0, that means I'm going to plug in here. Okay, so it's going to be 2 times -1 minus 1. 2 times -1 is going to be -2, minus 1 is going to be -3. So I have to plug in on the first piece. Let's do this one. F to the 3. Now f to the 3, that means this is the x. X goes with this condition or this condition?
Second one.
The second one, because it's greater than 0, because it's positive number. That means I'm going to plug in 3 on the second part of this function, the second piece. So it's going to be 3 times 3 squared. I'm going to plug in 3 here instead of the x. So it's going to be 3 times 3 squared is 9. So it's going to be 27. Now, if I ask you f to the 0, now x equals 0. This is the x. The 0 goes on this piece or this piece?
The first one.
Be careful. The first one, there is no equal
No,
sign.
I meant the first one you pointed at that one.
Oh, this one, the second one, yes, the second piece. That means you're gonna plug in because there's an equal sign here to the 0. So I'm gonna plug in 0 on the second one, 3 times 0 squared. So it's going to be 3. 0 squared is 0. 3 times 0 is going to be 0. That's how you're going to evaluate. Let's do another example about that. So it's going to be easier for you. So here's another example about the piecewise function. If you have f of x equal, this function contains 3 pieces. 7x plus 2, the first piece. The second piece, 7x So 7 minus, let's do 7 minus 7x. And the third one is a 3x. So here's the conditions, which is really important because by the conditions, we're going to know where we're gonna plug in the x. The first condition, when x less than or equal to the 0. The second condition, when x between 0 and less than 7. The third condition, when x greater than or equal 7. Let's first of all, let's study the conditions. The first condition, it says x less than 0. Less than or equal. Because when you know what's the meaning of these conditions, it's going to be easier for you. X less than or equal to the 0. That means all the numbers start from 0 and the negative. So it's going to be 0, -1, -2, and keep going to the negative part. So all the numbers, if they ask you 0, if they ask you x equal -1, if they ask you -2, -1,000,000, you can choose the first piece because this condition belongs to this piece. The second piece is telling you x between 0 and 7. Between 0 and 7, there is no equal sign here, there is no equal sign here. So I'm not going to choose the 0, I'm not going to choose the 7. All the numbers between 0 and 7, which is 1, 2, 3, 4, 5, and 6. All the numbers between 0 and 7. The third piece, which is when set x greater than or equal 7, check here. There's an equal sign. That means we're going to start from 7, 8, 9, and keep going to the infinity. You see, here is the 3 conditions. So you have to know what's the meaning of the condition. Now, I'm going to put this one on the side. And let's start working on these pieces. So here's the conditions. And we're going to start working on it. First one, if they ask you, find f to the 8. F to the 8, that means x equal 8. This is the x equal 8. X equal 8 goes to this piece or the second piece or the first piece. Someone tell me.
3x.
3x goes with the third piece. Why? Because here it says the condition, all the numbers greater than or equal to a 7. So it's going to be 7, 8, 9, and keep going. 8 belongs to this piece. So it's going to be 3 times 8. It's going to be 24. Now, if they ask you, find f to the 3, 2. F to the 2. Check f to the 2, that means x equal 2. X equal 2 belongs to which piece? The first piece, the second piece, or the third one?
Second.
The second one, because 1, 2, 3, which is all the numbers between 0 and 7, it's belong to the second piece. So it's going to be 7 minus 7 times 2. I'm going to plug in the 2 on the second piece. So it's going to be 7 minus 14, and it's going to be -7. If they ask you about find f to the -2, it belongs to which piece? Now x equal -2. Check -2. All the numbers less than or equal 0. That means the negative numbers or 0, because there is an equal sign here. -2 belong to this condition, so I'm going to use this piece. So going to be 7 times -2 plus 2. 7 times -2 is going to be -14 plus 2, and it's going to be -12. That's it. If they ask you about these pieces, this is the piecewise function and how to evaluate it. Now, next step, we're going to learn how to graph the piecewise function. Let's graph the piecewise function. This one is f of x equal to pieces, which is -2x plus 5. This is the first piece when x less than or equal to, and the second piece is x plus 1 when x greater than 2. You see the equal sign exists in one of these conditions. If it exists here, it's not going to be exist on the second condition. So now they give you this piecewise function and they're telling you, go ahead and graph it. So the first thing, I'm going to create a table to graph this piecewise function, and always do exactly the same table all the time. Always, here's the x, and now I need to find the y. This is the x, I need to find the y. You see, it's two pieces, so I'm going to put dashed line here. I'm going to use the first part to the first piece and the second part to the second piece. Just need a space. Always do exactly the same table. So now, this piece, x less than or equal to, I'm going to write down here. X less than or equal to, that means this condition belongs to the first piece. And here's the second piece. You see this dashed line? Write down the 2 here and the same number here. So we need 2 points here and we need 2 points here. So we can grab this piece and then we're going to grab this piece. Now, choose this number. You see, I didn't do anything. We didn't do math. We just write down, create this table, x, y. This is the first condition. I'm going to write down this number here. This is the second condition. I'm going to write down this number here, which is exactly the same number. Now, the condition says x less than or equal to. I'm going to choose a number less than 2. Choose a number less than 2. Choose the 1. On this part, now I'm done from the first piece. I have 2 x's. With the second part, here's the number 2. I need to choose a number greater than 2. Let's choose 3. Any number, 3, 4, 5. Let's choose the 3. Now we're done. We choose the x's. These 2 points belong to the first piece. So we're going to plug in 1 in the first piece. So -2 times 1 plus 5. -2 times 1 is going to be -2. -2 plus 5 is going to be 3. So the point is going to be x is 1 and the y is 3. I got the first point. Now, let's go to the second one, plug in the second number on the first piece. -2 times 2 plus 5 is going to be equal. -2 times 2 is going to be -4 plus 5 is going to be 1. So the second point is going to be the x is 2, the y is 1. we have 2 points. When we graph these 2 points, we're going to get the graph for the first piece. We're going to do exactly the same thing with the second piece. 2, plug in 2 now. We're working on the second piece, so we're going to plug in 2 on the second part. 2 plus 1 is going to be 3. That means this point, the x is going to be 2, and the y is going to be 3. 3, plug in 3 on the second piece, so it's going to be 3 plus 1 is going to be 4. That means x is a 3 and y is 4. We got 2 points for the second piece. Now keep in your mind, this is really important, which point I'm going to start so I can graph the first piece, and which point I'm going to use to graph the second piece. You see these 2 points near the graph? These are the start points. Start points. We're going to use this piece to graph the, this point to graph this piece, and we're going to use this point to graph the second piece. The start point. This condition contains equal sign, so I'm going to start with the closed circle. This condition doesn't contain an equal sign, so I'm going to start with an open circle. That's it. We're done from everything. Now the next part is just to graph these points. So let's graph these points by doing the coordinate, the x coordinate and the y coordinate. Always try to use a small number, so it's not going to be a problem when you graph it. So let's say 1. So let's graph these points. Here's the first piece. This is the start point. Always the points near the dashed line. So 2, 1. That means x is 2 and y is 1. This is the start point. I'm going to graph it as a closed circle. This is the start point, so I already know. This is the second point for this piece, 1, 3. So this is the 1, 1, 2, 3. Is going to be here. So these 2 points, a graph line on these 2 points to get the first piece. So I'm going to graph a line from the start point across to the second point and keep going to the infinity. That's why I told you this is the start point. So we're going to graph from the start point to the second point and keep going to the second, to the infinity. That's mean the purpose of the second point just to give you the direction where this piece go to here, 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 which side. So here's the start point for the first piece, and I get the direction for the graph for this line goes to this side. Now let's go to the second piece. This is the start point, 2, 3, an open circle, 2, 3. So 1, 2, this is the 2, and the y is a 3. So 1, 2, 3 is going to be here, an open circle. This is 2, x2, and the 3, 1, 2, 3, so it's going to be here. So this is the start point. The second point is 3, 4. So I'm going to get the direction by using the second point. 1, 1, 2, 3, 1, 2, 3, 4. So it's going to be here. You see, the second point is just to give me the direction for the second piece, which is going to be goes to this side. So I'm just going to graph a line from the second piece and goes to the infinity like this. So this is how to graph the piecewise function by create exactly the same table every time if you wanted to graph the piecewise function. Already solved it. We can see there's distance between these two pieces. This is the first piece, and this is the second piece. Sometimes when you graph it, maybe you're not gonna get a space between the two pieces. You're just gonna keep going. It depends about the condition. So let's try to do another example about how to graph the piecewise function. Let's do another example about that, how to graph the piecewise function. So here's another example. F of x equal, this is the first piece, which is 2x plus 3 when x less than or equal to the 0. And the second piece is negative x squared plus 3 when x is greater than 0. So I already know this is piecewise function because it contains two pieces. And the condition when the value of x equals 0 or less than 0, negative number, I'm going to use the first piece. And when the value of x greater than 0, I'm going to use the second piece. Now we're going to create exactly the same table. So we're not going to do any mistakes, and we're going to do exactly the same steps. So here is the table. Add the value of x, and we need to find the value of y. I'm going to write down here a dashed line. So the first piece is going to be here, and the second piece is going to be here. The first piece, I'm going to write down x less than or equal to the 0. And here's the second piece, I'm going to write down greater than 0. This one's going to be here. Now, 0 and 0, I'm going to write down 0 here and 0 here. Now, like I didn't do any math, we just creating the table. Now, on the first part here, they're telling you choose a number less than 0. We can't choose equal 0 because we already have 0 here. We need to get 2 points to grab the first piece. X less than 0, so let's choose -1. On the second piece, we have to choose x greater than 0. Let's choose 1 or 2. Let's choose 1. You see, the easiest number. Now, let's go back to the first piece. Let's plug in these two numbers here on the first piece. So the first piece is going to be 2 times -1 plus 3. 2 times -1 is going to be -2. -2 plus 3 is going to be 1. That means the first point is going to be the x -1 and the y is going to be 1. Let's do the second part, the second point. Let's plug in 0 on the first piece. 2 times 0 plus 3. 2 times 0 is going to be 0 plus 3 is going to be 3. That means the second point, the x is 0 and the y is 3. So we're done from the first piece. I already know this point near the dashed line. That means this is the start point for this piece. There's an equal sign, so the start point is going to be closed circle. Let's go to the second piece. Plug in these two numbers on the second piece. 0, plug in 0 here, going to be -0 squared plus 3. 0 squared is 0. There's no -0 because 0 is only number, so the result is going to be 3. So we got the point, x is 0 and y is 3. There's no equal sign at this point, so it's going to be an open circle. Now let's plug in this one with the second piece. -1 squared plus 3. 1 squared is 1, so it's going to be -1 plus 3 is going to be 2. So it's going to be 1 and 2. We're done. We have the table. We have 4 points, 2 points for the first piece and 2 points for the second piece. Let's graph these points and we'll see how the graph look like. Let's graph these points and we'll see how it look like the graph of this piecewise function. Let's start graphing the first piece. The first piece, here's the start point, 0, 3. So I'm going to start from this point, 0, 3. This is the 0, the y is a 3, 1, 2, 3. Close circle. And the second point, -1 and 1. So here's -1 and 1, so it's going to be here. That means this piece is going down like this, straight line from this point, because here's the direction for this piece, and goes down to the infinity. So I'm just going to graph a line from this point to the second point and goes to this side. I got the direction for this piece here. Let's grab the second piece. You see the second piece, the start point is an open circle, but is exactly the same point here, 0, 3, 0, 1, 2, 3. So this is also, I'm going to write down open circle, but it's at the same time, it's a closed circle to the first piece. So I'm going to start from the same point here. The second point is 1, 2. This is 1, 1, and 2 is going to be here. So it's going to be like this. The direction for this point. You see the difference between this example and the previous one, there is no space between the two pieces. This is the first piece and this is the second piece, but these two pieces are connected at this point, which is at the same time closed circle and at the same time open circle. So we're going to do exactly the same steps. Create the table. This is the X. I'm going to find the Y. I'm going to put dashed line here. So I can know this is the first piece and here is the second piece. X greater than or equal 1. X less than 1. Now you see these 2 points, 1 and 1. I'm going to write down 1 and 1 here. Let's start graphing the first piece. I need to choose a number greater than 1. Choose a number greater than 1. Let's choose 2. Here, we're going to choose a a number less than 1. Let's choose the 0. Now we have 4 points for x's. We're going to plug in the first 2 x's on the first piece. Check here with the first piece. There's no x. This is really important because you get confused where I'm going to plug in 2. So when x equal 2, y equal 3, because you can't plug in the 2 here. Y equal 3. When x1, y also 3. Because there is no x here to plug in the number. So when you have just a number by itself, that means this is the y value. When you have any x here, x is 2, 3, 4, 5, 6, any x with this condition, with the first piece, the y is going to be 3. So the first point here is going to be 2 and 3. And the second point is going to be 1 and 3. I already know this point near the dashed line. That means this is the start point. There's an equal sign with the condition. So it's going to be closed circle. So this is really important because you can't plug in these numbers here. So The y value is going to be fixed point, 2, 3, and 1, 3. Let's go to the second piece, x less than 1. 1, we're going to plug in the 1 here. So it's going to be -1 minus 1 is going to be -2. That means this piece, the x is 1, and the y is -2. Plug in the 0. -1 minus 0. So it's going to be -1. So it's going to be 0 and -1. This is the start point. So no equal sign. So it's going to be an open circle. Now let's graph these points. The first piece, this is the start point, 1, 3. So this is the 1, 1, 2, 3. And here is the 3. It's a closed circle. So here is the start point, which is a closed circle. The second point, 2, 3. 1, 2, this is the 2, and the 3, 1, 2, 3 is going to be here. You see, the second point always to give me the direction for this piece. So the direction goes to this side. So it's going to be just a line start from this point and goes to the infinity. Now we're done from the first piece. Let's grab the second piece. The first point, the start point, 1, -2. So this is the 1. So this is the 1. -2, 1, 2. That's mean here. The start point is an open circle, so I have to graph open circle. The second point, 0, -1. 0, -1. This is the second point. That means the second piece is going to be started from this point, go to the second point, and keep going to the infinity. That's it for this example. If they ask you about the function, is this function is continuous or no? I'm going to give you 2 examples. So for this function, if you graph this function, and when you graph it, you're not going to leave the pencil from the paper. You see, it's just a line. So this function is continuous because you're going to graph it without lifting the pencil from the paper. So we're going to call this function, and there is no hole here inside this function. Here's the function is not continuous. It's the same thing, but there is a hole here. So there's a space here. That's why we're going to call this function is not continuous. That's the only thing I need you to know about continuous function and not continuous function. If you see a small circle here, an empty circle here, you're just going to say this function is not continuous because you're going to graph it like this. Then you have to move to this part and graph it again. So we're going to say this function is not continuous. This function is continuous because when you graph it, you're going to graph it as a straight line without leaving a hole here. That's it. That's the only thing I need to know about continuous function.